Picture this. You're on the sofa, relaxed, watching your team play. It's evening, the match just ended, and you're about to head to bed. Your phone rings. It's work. There's an incident. A critical part of the application is down. The deployment that went out earlier that day broke it. And it's your turn on call. Here's the part that makes it worse. There are no tests covering that functionality. So now you're not just fixing a bug. You're reverse engineering what the code was even supposed to do. At midnight, under pressure, deciding between patching it forward or reverting the PR and dealing with whatever that reversion breaks downstream. That night doesn't happen because someone wrote bad code. It happens because the logic that actually mattered, the part deciding what's valid, what's allowed, what the business rule was never separated from everything else enough to be tested on its own. It was buried inside a component, tangled up with rendering and state and API calls, and nobody could write a clean test for it even if they'd wanted to. This is the pattern. It repeats on every team that doesn't draw this line early. By the time you're the one getting paged for it, the cost isn't measured in lines of code. It's measured in how long it takes someone to even understand what the system was supposed to do before they can fix it. Worse yet, it makes the application incredibly fragile and difficult to test. As software engineers, what we do carries a lot of responsibility. Our code has real-world impact, and bugs can have serious financial or safety consequences. We tend to think that when we press a brake pedal in a modern car, we are controlling a mechanical lever. We aren't. We are sending a signal to an onboard computer. There have been cases where software bugs in these systems led to serious injuries. Thorough testing is not a luxury. It is a requirement. To test logic, that logic must be extractable. Pulled out somewhere, it can be checked on its own, without dragging half the application along with it. This is why separating business logic of your components is important. There are many ways how to achieve this. In the previous video, we covered clean architecture at a high level, separating concerns and how clean architecture could help so that the codebase doesn't end up here. In this video, I focus on the domain layer. Think of this as your types, entities, and business rules in their purest form. No React, no API dependencies, no external libraries. This is what the entity is in your system. Not what the API returns, not what the UI renders. What it fundamentally is. No React, no fetch, no third-party library. Nothing from the outside world. So where does that extractable logic actually live? It starts with what's coming in. Every piece of data entering your app starts life as a DTO, a data transfer object. DTO stands for Data Transfer Object. A DTO is a stateless data structure designed exclusively to carry raw data across the boundaries of different application layers. Its primary job is to ensure that the core domain layer, entities and use cases, remains completely decoupled. In simple terms, your API request/response objects, or the partial temporary objects you construct when you call some service, is a DTO. Think about like DTO is just a fancy name for a temporary object. Real APIs are rarely tidy. Data from legacy systems or third parties often arrives unnormalized. A JSON string stuffed into a generic metadata field. Numbers represented as strings. One of the most common mistakes is using the same structure for your API response and your application state. If you use TanStack to simply mirror the server response, you are tightly coupling your frontend to your backend's implementation details. You can't run business logic against a shape like this. In complex apps, you often need to transform a DTO into an entity. You might need to combine data from two different endpoints or parse raw strings into proper formats. So the mapper does the parsing once. JSON parsed, strings converted to numbers, VAT resolved. What comes out the other side is the entity. the clean, framework-agnostic shape that represents what this thing actually is in your business, independent of the framework, the transport, or how the data happen to arrive. By performing this transformation, you create a single place to handle errors and parsing logic. If the tire shop later adds a product type that requires calculating price per hour, example, a service like tire change, wheel balancing, tire repair, puncture, etc., you don't change your components, you only update your domain logic. When implementing this on the front end, I take a pragmatic approach. In a backend environment, you might use classes to define entities and their rules. In React, forcing classes into your domain often feels unnatural and overcomplicated. Keep it simple. Define your entities as types and your business rules as pure functions. If we look at this code, we can see that width is already a number. Price with VAT is already resolved. No component downstream ever touches a raw string or runs the VAT lookup itself. Skip this step and that parsing logic doesn't disappear. It shows up scattered through your UI as if equals tire checks instead. And because the entity is this clean, the business rules built on top of it are trivial to write and trivial to test. No imports from React, no fetch, nothing from the outside world. Call it with a value, check what comes back. That's the whole test. This is exactly the kind of function that, left untested and buried in a component, is what turns a routine deployment into an incident report. If you continue using the DTOs, then you will end up having if-else cases everywhere in the codebase. Have a separate dedicated type would make it much easier to have a clear separation up front and would influence how you write your components and test everything easily. That's why keeping your logic centralized is so important. This is what makes a backend change, say swapping REST for GraphQL, a one-file update instead of a rewrite. The DTO shape changes because the transport changed. The mapper absorbs that. The entity and the business rules never move, because nothing downstream ever depended on REST or GraphQL in the first place. Worth mentioning is that moving the logic in the domain layer and defining the entities and DTOs is just the start. It would not make the codebase clean, but it will help to get there. Simply think about it this way. If the logic it involves parsing, calculation, or rules the business actually cares about, it earns a place in the domain. A codebase doesn't turn into a 1,000-line file or a 2 a.m. incident from one bad decision. It gets there because business logic and UI logic were never given a boundary, so they grew into each other until separating them felt impossible. Do not over-engineer simple served apps. If your application is just a thin wrapper around an API, displaying a list and a delete button, adding a domain layer, DTOs, and mappers is a waste of time. Only introduce these boundaries when the complexity of your business rules or the messiness of your data justifies the boilerplate. Next, connecting this layer with application layer. Why dependency injection earn its place, and what is use case-driven development? Thanks for watching, and if you like this content, share, like, subscribe, and see you in the next video.